Welcome in dark core. The sun was expected to stay quiet, but instead it's growing stronger, unleashing storms and raising questions scientists can't yet answer. In this video, we'll explore why this unexpected surge has caught researchers off guard and what it could mean for our future in space and here on Earth. What scientists discovered. The surprise began when solar cycle 25 officially started in December 2019. At the time, predictions described it as a weak cycle, possibly weaker than its predecessor. That expectation was based on long-term trends. For decades, solar wind strength and sunspot activity had been declining. Many believed we were entering a prolonged minimum, similar to quiet periods seen in past centuries. Instead, activity started climbing. By 2023, sunspot counts were already well above forecasts. In 2024, it produced a series of storms strong enough to disrupt communications and paint vivid auroras across much of the globe. These events signaled that it was not following the expected script. To investigate further, NASA researchers Jamie Jasinski and McCoy examined solar wind data stretching back to 2008. They found a consistent rise in nearly every measure: speed, density, temperature, pressure, and magnetic field strength. This was more than a temporary surge in sunspots. It reflected a broad strengthening of the output across multiple indicators. The result was a clear reversal of the previous downward trend. The forecasts had missed it, not because of poor data, but because it had shifted in a way models didn't anticipate. This matters because solar forecasting is notoriously difficult. Even with centuries of sunspot records and decades of satellite monitoring, it often surprises us. Its magnetic processes are complex, and the links between surface activity, internal flows, and longer-term cycles remain only partly understood. What began as a mismatch between prediction and observation has now become a deeper puzzle. Why did it grow more active after such a weak cycle? And what does it signal about its longer-term behavior? Why this matters for science. The unexpected rise in activity challenges the way scientists think about the solar cycle. At its heart lies the solar dynamo, the process that generates the sun's magnetic fields. Models suggested that weakening winds and fewer sunspots pointed to a prolonged quiet phase. Instead, since 2008, the opposite has occurred. One idea is that the Hale cycle, a 22-year magnetic rhythm, plays a larger role than previously acknowledged. Each 11-year solar cycle may be just half of this longer process. If that's the case, then what looked like a weak period could simply have been one part of a bigger pattern. Historical records add another layer of uncertainty. The Maunder minimum, 1645 to 1715, and Dalton minimum, 1790 to 1830, both showed how unpredictable it can be across decades. Neither event is fully explained, but both demonstrate that it can depart from its usual cycle for extended periods. The recent reversal may represent another such shift, though in the opposite direction. For researchers, this is more than an academic curiosity. Reliable forecasts are critical for space missions, satellites, and infrastructure planning. Underestimating the strength increases the risk of being unprepared for major storms. The surprise also creates an opportunity. Spacecraft like the Parker Solar Probe and Solar Orbiter are already gathering data from unprecedented vantage points. Their instruments are designed to probe the magnetic environment and solar wind in detail. Observing during this unexpected upswing may help scientists refine their theories, offering insights into processes that drive the solar dynamo. The sun's reversal underscores the limits of current models while opening a chance to test them in real time. For solar physics, it's both a challenge and a moment of discovery. Implications for Earth and space. A stronger sun carries practical consequences. The most immediate are geomagnetic storms triggered by solar eruptions. When charged particles from it interact with Earth's magnetic field, they can disrupt GPS signals, radio communications, and satellites. Recent storms have demonstrated how quickly these effects can spread worldwide. Power grids are also at risk. The 1989 Quebec blackout caused by a solar storm showed how vulnerable infrastructure can be when currents induced by solar activity overload systems. Today's grids, heavily reliant on interconnected networks and electronics, may be even more exposed. For astronauts and future space missions, the stakes are higher still. Solar storms increase radiation exposure, complicating missions to the Moon and Mars. Planning for long-duration travel now requires stronger protection and constant monitoring of space weather. But the implications aren't all negative. A more active sun provides unique opportunities for observation. Scientists can study storms, flares, and solar wind under conditions they didn't expect. Using the wealth of data from current missions, this could lead to better predictive models and more accurate warnings in the future. There are also cultural and visual effects. Strong storms generate auroras visible far from the polar regions, giving people around the world a rare chance to see the northern and southern lights. While this is a small benefit compared to the risks, it highlights the dual nature of solar activity, both a hazard and a source of awe. The key question is whether this upward trend will continue or stabilize. So far, solar wind strength remains below levels recorded in the early 20th century. That suggests we are not yet in unprecedented territory. Still, the mismatch between forecasts and reality is enough to keep scientists cautious. The lesson is clear: the sun is unpredictable, and we must be ready for its surprises. Outro: the sun was expected to be quiet, but it's waking up with more power than predicted. Its future remains uncertain, and that's why we'll be watching it closely. Subscribe to stay updated on the mysteries of our star. Thanks for watching Dark Core.